Okay, so yesterday we discussed increasing and decreasing intervals. Okay? On Monday we talked a little bit about relative minimums and maximums, but we really just focused on absolute minimums and absolute maximums, right? We talked about the concept, but then we kind of pushed it to the side. Okay? Today we're going to take what we know about increasing and decreasing intervals, and we are going to determine when we have minimums and maximums, relative minimums and maximums. Okay? So I want to take about a minute, and I want you to talk about, like maybe even flip to an example from yesterday's notes. If we identify when our function is increasing and decreasing, how could that help us determine relative minimums and maximums? Go ahead and talk about it with your thoughts. Okay. So let's see. Pod 5, did you come up with anything?
The critical numbers.
Okay, the critical numbers are our potential minimums and maximums. How do we determine which one is which?
If it's a negative going to a positive, then it's a minimum. If it's positive to negative, then it's
Okay, this is what you just said. It's not kind of quiet, so I'll say it again. If you're talking about the derivative, right?
yeah.
If the derivative goes from negative to positive, we have a minimum. If the derivative goes from positive to negative, we have a maximum. That's what he said. What do you think about that? Does it sound reasonable? If we go from decreasing to increasing, we have we make like a valley, right? We're going to have a minimum. If we go from increasing to decreasing, we're going to change directions. Kind of like a hill, we're going to have a relative maximum. That is exactly what the first derivative test is. Okay? If we find our critical points, and at our critical point, our derivative changes from negative to positive, we have a relative minimum. If at our critical point, our derivative changes from positive to negative, we have a relative maximum. That is the first derivative test. It really is not any more work than what we did yesterday. We're just identifying an extra piece of information from yesterday. Could there be times where the sign of the derivative does not change? That is possible. If that's the case, then we don't have a relative minimum or a relative maximum there. It's a critical point, but it's not a minimum or maximum, and that is okay. Ready? Now, while I'm waiting on a couple of people to finish up, there will be times where I ask you to justify whether a coordinate is a relative minimum or a relative maximum. The justification is this right here. If your derivative changes from positive to negative, if your derivative changes from negative to positive, those would be your justifications for if you have a relative minimum or maximum. Okay. So, here we go. Does this look familiar? Why does it look familiar? It was in the lesson yesterday. Okay? So, really, I want to just build off of what we did yesterday. Okay? So, let's talk about what we did yesterday. To find increasing and decreasing intervals, what did we do first? Okay, we found the derivative. And then what did we do with the derivative?
Equal to 0.
We set it equal to 0. So we found critical points of, what's my mistake? Don't forget to label your number line. Okay. Then what did we do? We tested. So if we plug in -3, we got a, hold on, let me think, positive value. We plug in 0, we get a negative value for our derivative. If we plug in a +3, we got a positive derivative. So we identified our increasing intervals to go from -infinity to -2 and 2 to infinity. And our decreasing interval, -2 to 2. Okay. Now, the one extra step for the first derivative test is to identify from this number line our minimums and maximums. Okay? The only time a relative extrema will occur is when there is change in the derivative. So here at -2, there is a change. It's changing from positive to negative. What's happening at -2? There is a maximum. So right now I'm just going to say this is I'm just going to make a little note to myself. At 2, the derivative changes. The derivative changes from negative to positive. What's happening at 2? There is a minimum. Okay? So here, in part B, I asked to determine just the x values of local maximums and local minimums and justify. So we decided there was a relative maximum at x equals -2. Abram, what would we write for justification?
The change direction is from positive to negative.
Be careful. What is it? Okay. So, right, you need to say the derivative, or you can say f prime changes from positive to negative. Then we labeled min at 2. So we have a relative minimum at x equals 2. Josie, what would our justification be for that?
The derivative changes from negative to positive.
Our derivative changes from negative to positive. Really not going to feel that much different from yesterday, right? We're doing all the same work, all the same calculus, all the same algebra. One extra step is just identifying where we have. So let's go ahead and do this. You guys all have your notes from yesterday, right? Go to this one. Okay, so yesterday we found our derivative to be this. And we identified critical points at 0, 2, and negative 2. This is the same as yesterday, right?
We did 9.
Oh, shoot, is this different? Well, then, let's start over.
It was just nice. So
It's the exact same thing, except it's just the numbers. So it's.
Okay, so should we do this? Okay, so yesterday we decided our derivative, it was 2x. Oh, no, it was 4x, right?
Yeah.
Like that?
Yep.
Okay. And our critical points were x equals 0, 3, and negative 3. So our number line looks like this. What sign value is this? Okay. So, looking at that sign chart, let's identify when we have a change in sign value. So here at negative 3, does it change? Derivative goes from negative to positive. This, Isaac, what does that mean? Relative what? Minimum. So I'm just going to label minimum. We'll come back to that. Okay, from here we change, the derivative changes from positive to negative. Austin, what do we have?
The relative mass.
Here we change from negative to positive. Madison, what do we have? Okay. Okay, so let's go ahead and identify those values. Okay, we have a relative min occurring at negative 3. How do we figure out the y value? Plug it back in. So let's come up here to the original. What is negative 3 squared? Minus 9? So negative 3, 0 is our relative minimum. We also have a relative minimum at x equals 3. So it's going to be what? That's also 0, right? Then we have a relative maximum at x equals 0. When we plug 0, we get negative 9 to the 2/3. we get radical cube root of 18. No. Did we say, hold on, we said negative 9 to the 2/3 cube root of 81, right? Because we're going to square negative 9 and then cube root it. Questions? Okay, let's do a problem on our own. So we come back to our notes. I'm actually, I know, it didn't get saved. I'm really sorry. That's really what I want. Okay, so we want to find the relative extrema. Anytime I ask you for relative extrema, we need to find the first derivative so we can determine critical points. Go ahead and find me the first derivative using what rule? Quotient rule, and then simplify. You wouldn't have to use the quotient rule. You could do something else, but no matter what, it needs to be simplified to one fraction in the end. Okay? Gina, do you have your derivative? Not yet? Go ahead. Compare it to your neighbor when you have it.
That's square minus 1.
Gina, did you come up with something? Gina got x squared minus 1 over x squared. Do you agree? I agree. Does anyone need me to go through how to get there? Agree?
Well, we need to find it.
So,
So I would just leave this as x squared minus x squared is x squared. So we have x squared minus 1 over x squared. So what you have is like, you have a fraction and a fraction. Since we have to figure out where we're going to want to make that one fraction. Okay, so you would want this to be x squared over x squared.
do you?
Okay. Now, some of you may have broken that up and then taken the derivative, and you would have gotten to like here 1 plus 1 over 1 minus 1 over x squared. Okay. When you are doing the either increasing, decreasing intervals or first derivative test, since we have to identify critical points, if you have one fraction in your derivative, you want to make the entire expression a fraction so that you can identify where it is 0 and undefined. So you want to go ahead and common denominators to get to here. Okay? So then, critical values. When is our derivative equal to 0, Cole?
It's equal to 0 at
Plus or minus 1. When is our derivative undefined, Josh? Okay, so we have 3 critical points. Okay, now, before we go any further, I want us to consider the kind of function that we're actually dealing with. What is happening at x equals 0 in our function? It is an asymptote. So if there is a change in the derivative, can x equals 0 be a relative extremum? It cannot. Okay, so it's good for us to think about that. All right, we still need to test all of the intervals because we need to know when this function is increasing versus decreasing. But we know that 0 can't be an extremum. All right, so go ahead and work together in your group. Go ahead and test those intervals. Maybe each of you pick an interval to test. There's 4 intervals. There's 4 people at a table. Okay. Let's see. Trevor, which interval did you test for your group? And what is it? Okay. Joe, give me an interval. There. Okay. Jake, give me another interval. Oh, both of these are negative? Okay. So, this is okay. All right. Negative to negative. There's not a relative min or max there. Good thing, because it's an asymptote. Cold, April, chill. Settle down. Okay, so Logan, what's happening at x equals 1? Why?
Oh, at -1, it's a max. I like that at 1.
Did I? We'll go with 1, since that's what you thought I said. Why is it a minimum?
Because the derivative is going from negative to positive.
Very good. So our relative minimum occurs at x equals 1. And what is that minimum value? When we plug 1 into our equation, we get 2. Okay. Aaron, what's happening at -1?
Max.
How do you know?
Because the derivatives are positive.
Excellent. And so at -1, we have a maximum. That maximum value is 2. Yes.
Do you have to say anything for 0? Like, how looks like no change.
Nope. If I'm asking you to identify the relative extrema, you can stop there.
So, what would you be asking?
So there will come a time next week where we will take these relative minimums and maximums, our decreasing intervals. We're going to take tomorrow's concept of concavity, and we're going to draw a graph based on everything that we find. And so that is when the asymptote will become important. Okay? All right, let's come back to the concept of reading graphs. Okay? What?
For the last one,
Uh-huh.
for the maximum,
Uh-huh.
should it be -1, -2? Because it's a...
Yep, it should be. Thank you. Thank you for catching that. Okay, so I'm going to give you and your group an activity to do here where we need to determine the x-coordinates of relative extrema. Okay? So if this is the derivative, right? Where would our critical points be? At the zeros. So that would occur at -1, 0, and 1, right? So if we had a sign chart, to the left of -1, our derivative is positive. Between -1 and 0, our derivative is negative. Between 0 and 1, it's above the x-axis, our derivative is positive. And to the right of 1, our derivative is negative. Okay? So we know that we have maximums at x is 1 and x is -1. Whoops. And a minimum at x equals 0. Now, if we only know information about our derivative, do we know the actual coordinate for our graph? Okay, we do not. So if I give you a derivative graph, the only thing you can tell me about the relative extrema would be their x values. So what I'm going to do, I'm going to give you this piece of paper. And as a group, I want you to look at 1 and 4. Excuse me, not 1 and 4. That was silly. 1 and 3. Do you see how 1 and 3 look the same? In number 1, I'm giving you the function graph. In number 3, I'm giving you the derivative graph. So please answer those questions for me. I'm going to give you about 3 minutes.